Hey everyone, so if you're getting into Go, one of the first things you'll notice is that there's no class inheritance, which can be a bit of a shock if you're coming from other languages. Today, we're going to unpack one of Go's most elegant answers to this, a really powerful concept called type embedding.
All right, here's what we're going to cover. First, we'll talk about the problem Go is trying to solve. Then we'll see how embedding works its magic on both interfaces and structs. After that, we'll hit a super important point about how this is not what you might be used to. And finally, we'll wrap up with some everyday uses and the rules you need to know. You know, if you've spent years working in languages like Java, C#, or Python, one of Go's biggest design choices can feel, well, kind of weird at first. And that is the million-dollar question, isn't it? Go just straight up doesn't have the kind of subclassing you see everywhere else. So how in the world does it handle something as basic as reusing and building upon existing code?
The answer is this really clever idea called embedding. Instead of creating a family tree of types that inherit from each other, Go lets you borrow functionality by literally putting one type inside of another. Think of it less like inheriting your dad's traits and more like just grabbing his toolbox.
Okay, let's start with the simplest and cleanest example of embedding. You actually see this all over Go's standard io package. It's super clean, really simple, and incredibly effective. So, in the world of input and output, you have these two fundamental building blocks. You've got a reader, which is anything you can read bytes from, and you've got a writer, which is anything you can write bytes to. Two simple, very distinct jobs. And here is where you see that Go elegance in action. To create a new interface that can do both, an io.ReadWriter, Go doesn't make you list out the read and write methods all over again. Nope, you just embed the two interfaces directly. It's just a clean, logical union of their method sets. If you are a read writer, you absolutely must be a reader and a writer.
Now, that same idea works for structs, but this is where the concept really takes off and gets incredibly powerful. With structs, embedding saves us from writing so much boring, repetitive code.
Just look at this slide. It says it all. On the left is how you might do it without embedding. You'd have to create name fields, and then for every single method, you'd have to write these annoying little forwarding functions. But look at the right. With embedding, you just list the types. That's it. The methods from reader and writer are just there. They're promoted automatically. It's like magic.
So the big win here is that we get to skip all that manual labor. Our outer struct doesn't just get the methods, it also automatically satisfies all the interfaces of the types it embeds. So something like a io.Reader just instantly becomes an io reader, an io writer, and an io.ReadWriter all at once. Okay, but, and this is a big but, this is where we hit the most common stumbling block for folks coming to Go. Embedding looks a whole lot like inheritance, but there's a critical difference in how it actually works under the hood.
I mean, it seems perfectly logical, right? You've got your myReadWriter variable, you call the read method on it, you'd naturally assume that myReadWriter is the thing receiving that method call.
And the answer is a hard no. This right here is the absolute key difference between embedding and subclassing. The receiver of that method call is not the outer type, not at all.
Here's how to think about it. When you call myReadWriter.read, what's happening is exactly the same as that manual forwarding method we saw a minute ago. The call is just passed through to the embedded reader field. That method belongs to and operates on the inner type, not the outer one. The outer struct is just a convenient pass-through.
All right, enough of the heavy I/O stuff. Embedding is also just a fantastic tool for making your own code way more convenient. Let's look at a much more common, everyday example. So check this out. We've got a job struct, it has a command it needs to run, and we've also embedded a pointer to a standard library logger. That's it. Just by adding that one line, our job type now has all the logging methods like print, printf, and printline available directly on it.
So once you create a job and give it a logger, you can just call job.println directly. It's so handy. And if you ever need to get to the logger itself, maybe to change where it writes to, no problem. You can access it directly by using its type name, logger, as the field name.
Okay, this is probably what you're thinking right now. What happens when names clash? What if our job struct and the embedded logger both had a field named, say, status? Well, Go doesn't leave you guessing. It has very simple, predictable rules for this.
Rule number 1 is dead simple. The outer type always wins. Period. If our job struct has its own field named command, that will always hide any command field from something it embeds. The thing that's closer to you always takes precedence.
And rule number 2 is just as clear. What if you embed two different types, and they both have a method called start? Well, Go isn't going to flip a coin. It's going to say, whoa, I don't know which one you mean. And it will give you a compile time error. It forces you to be explicit, which is a core part of the Go philosophy.
This quote from the official Go documentation really just nails the whole idea. Embedding isn't inheritance. It's a powerful, clean, and explicit form of composition. It's all about building bigger things by snapping together smaller, focused components.
So when you boil it all down, Go's design is constantly pushing you towards this model of composition over inheritance. And that leaves us with a really interesting final question to think about. Is this just a different style, or does it represent a more fundamental principle about the best way to design robust and maintainable software from the ground up?